chapter 15 over Earth's natural resources. We're going to be starting with lesson 1, the Earth's resources. So vocab for lesson 1, we have 6. Atmosphere is a mixture of gases that forms a layer around the Earth. It's important to remember this is a mixture of different types of gases, different elements of gases, or compounds of gases. Geothermal energy is thermal energy from within the Earth. Inexhaustible resources are natural resources that will not run out no matter how much people use it. Natural resources are part of the environment that supplies a material that is useful or necessary for the survival of living things. Non-renewable resources are natural resources that are being used up faster than we can replace it by natural processes. And renewable resources are natural resources that can be replenished by natural processes at least as quickly as it is used. And we'll talk about those a little more as we go on. So a quick list of just some of the kinds of natural resources that we'll be looking at. We have land. We might not think of that as a resource very often, but obviously if it's where we grow a lot of our food, it's going to be a pretty important resource to us. Air is another one because we need clean air to breathe. Minerals we'll talk about a little bit more. Those are going to be really important for humans and animals and plants. Fuels are pretty important to humans. Trees, water. Again, these are all things that humans and other organisms use on the earth to live. Alright, so non-renewable resources. These are, again, the resources that are not being produced as quickly as they are being consumed. So they form slowly in crusts by way of pressure or compression and heat. You need both of those two elements to make a non-renewable resource. A lot of these include fossil fuels. Once fossil fuels are burned, they cannot be reused. Our first example here is going to be coal. When coal is mined from the ground, the way we use it is to heat the coal, and then from the burning coal, we use that fire and that heat to heat water. When we have that water being heated, steam from that water is then used to turn a turbine, and that turbine is what generates electricity. So that's how we actually create electricity from coal. So we go through that water step first. Another fossil fuel would be oil, and that's drilled from the ground, just like coal is mined from the ground. There's a lot of different things that are made out of oil. Obviously, we think of gasoline, diesel, jet fuel, right? Those are just fuels. Big one is plastics are made out of oil as well. That's something to keep in mind. So when we're talking about recycling later on, you can think how if we recycle our plastics, we're going to be able to save a little bit on having to drill out more oil and more fossil fuels. Natural resources, or excuse me, natural gas is also drilled from the ground. A lot of times we'll get natural gas and oil at the same time. It's used in power plants in the same process that coal is used. It's used to heat water to turn a turbine. It's also used to heat houses and businesses. Propane is one of the gases in natural gas. So propane is just one compound. Natural gas is a mixture of a lot of different gases. So propane is used in grills and can be used in vehicles. We're talking about vehicles here, we're talking about like skid loaders and things like that, and in houses. So when we're talking about heating houses and businesses, if you've ever heard somebody say that their pilot light went out, that's what happened. They have a house that's heated by natural gas or propane, and that pilot light goes out, and that's what heats the house. Today's primary source of energy is fossil fuels, whether that be natural gas, coal, or oil. We use a lot of fossil fuels. I'm sure you've probably talked about this and heard about it before. It's something we're trying to get away from. We want to decrease our dependency on fossil fuels. So, one last non-renewable resource is going to be minerals. So minerals some can be reused, so scientists say that they're less non-renewable, only because they're non-renewable because they're not being created as quickly as we're using them, but because they can be reused, they're not quite as endangered to run out. Some are very plentiful. They form underground by heat and pressure, kind of almost exactly like our fossil fuels. They're non-living substances found in the Earth's surface, or the Earth's crust. The things, the minerals can be used in fertilizer, things like phosphorus and potassium. Humans need different minerals, and remember, what we're looking at here, these are actually elements, but these elements are found within different minerals. So we need iron for our blood, calcium for our bones, and potassium. I mean, we've probably heard that keeps us from cramping up. So here's the relationship between rocks, minerals, and elements. So a rock, right here, is made up of granite, right? That granite is made up of these minerals. So quartz, feldspar, and boatite are all minerals. And those minerals are then made up of elements. So rocks are made up of minerals, minerals are made up of elements. So in this example, quartz is made up of silicon and oxygen. Non-renewable resources. They get replaced in a relatively short time. Um, we can replace them almost as quickly, if not as quickly, as we can consume them. They're replenished by natural processes. So this is trees growing. Um, Air goes through a process of a cycle, kind of like water does. But in this case, we're going to be talking mostly about the composition of the air, and we've talked about this before. We have our atmosphere is 78% nitrogen, 21% oxygen, and it's only 0.4% carbon. And that's not even the third largest. There's actually one that's larger, or a few that are larger, but we always talk about carbon dioxide. So it's important to realize how small of a percentage that carbon dioxide really is in this case. Land is a renewable resources. Having fertile topsoil is very important. If you go somewhere where they can't really grow plants, then they depend on other people to get food to them. So here in Nebraska and in the Midwest in general, we're really lucky because we can make our own food. But if you're up north, say you're really, really far north in Canada and the topsoil is tundra and it's always icy and you can't really grow anything in there, then you have to rely on other sources of food. So topsoil can be washed away by water or blown by wind. Would be erosion. It takes a very long time to rebuild that topsoil and make it um, nutrient rich. You make it nutrient rich by having plant or animal decay in the topsoil. So that's the recycling of animals in this case. So here we have a table of what our atmosphere is actually made up of. So nitrogen is 78%, oxygen we said is 21, so we're rounding that up a little bit. Argon, which is a gas, is at almost 1%, and then you see carbon dioxide, which is fourth at 0.4. So that makes up like a really, really small percentage. And then we have some other really, really trace things that are almost non-existent. Renewable resources, we're going to talk about water for a second. Hopefully we know by now that water goes through a cycle. All organisms need water. Populations are limited by the amount of usable water. Usable is a really important part to think about because we can't really drink. We can, but it's really bad for us to drink salt water. So even if you're really close to a lot of water, just because you're close to a lot of water doesn't mean you're close to a lot of usable water. So fresh water is renewed in that water cycle. Hopefully you remember that. About 96% of the Earth's water is salt water. So that's water that's not drinkable. We can't really use that for a whole lot. People have many different uses for water: irrigation, washing, drinking, transportation. We also have different setups to get water to us, right? We've, or hopefully you've heard of the aquifer and being able to, we're lucky because we're right over top of one that supplies a lot of our drinking and groundwater. Alright, so the way we read this graph is that this top this top pie chart is all of the water on Earth. 97% of that water on Earth is salt water. So that's what saline means. Saline means salt. So 97% of the Earth's water is salt water. That leaves 3%, that's all. 3% that's fresh water that we can actually drink. So then they're going to take this slice out and turn it into its own pie chart. And of the 3% of all of the water in the world that we can drink, almost 70%, 68.7, is locked into ice caps and glaciers. That's a really, really big amount. So, of the 3% we could possibly drink, 70% of that we can't really use because it's in ice. Then we have 30% is groundwater, and that's what we can actually use. So, then they take the surface water right here, which is 0.3, or excuse me, we can't really use the groundwater. We can to a degree, but it's not the water we think of when we just think about lakes and things like that. This would be aquifers located underneath of, say, Nebraska. I'll see if I can find some more information about that, and we'll bring that up. But of this little sliver right here is surface water, and that's 0.3% of 3%. So that's an incredibly small percentage of water that's actually surface water. Of that, 87% is made up of lakes, 2% is rivers, 11% swamps. The real take home here is that the amount of water that we can actually use is really, really small compared to the amount of water that's actually on Earth. Alright, so inexhaustible resources. This might be the one that you might not have talked about. We can use these as an unlimited amount. We're never going to run out of these things. So these would be solar, wind, and geothermal. So solar is obviously energy from the sun. It provides heat, or light, heat, and almost all the energy to the earth. We use it in greenhouses, plants, homes. We use it to power solar plant panels. Our next one's going to be wind power, produced by the sun's uneven heating of the atmosphere. So hopefully we have heard that hot air rises and cold air sinks. If we have one spot getting hot, then we're going to have that area start to rise. And when that happens, we have cold air move around and hot air starts to move around. And that's what actually causes the winds. So we use the turbines to produce electricity off of those winds. And I'm sure you've seen the really, really big windmills. Next is going to be geothermal energy. We use the pockets of magma, or called magma plumes, is how you pronounce that word, plumes, rise near the Earth's surface. This heats the groundwater and the rocks. The heated water produces steam, which is what we use to power our turbines. When we talked about coal and natural gas, we talked about using the steam off of burning those things to power turbines. So here we're not having to burn something. We're harnessing the magma's energy within the earth to do that. Alright, so this is how a solar panel works. It's really pretty simple. We have the sun's energy come down and strikes the solar panel. The solar panel transfers the energy to a usable form and charges essentially a chemical battery, and that chemical battery is able to power other things. This is how a wind turbine would work. The wind turns the turbine blades, spins the shaft, creating electricity. So in here we actually have resistance, and that's what creates the electricity. The inverter converts electricity from direct current to alternating current, is what that means. Don't be too concerned about that. Electricity is connected directly to the mains power, or connected to a battery bank, or connected to an electric grid. I'm not sure which of the three the turbines around here use, but the main take home here is that these are able to produce power, and we can use those for all three of those different sources. And our last example is the geothermal energy. Here we have, down here would be our heat source, right? So we'd have the hot magma probably down in this area somewhere. And what we do is we pump cold water down, and then as it works over towards the heat source, it starts to heat up. we have another tunnel, or another tube that is available for the hot water to rise back up. So when the steam starts to rise up, we have a turbine right here, and those turbines are what harnesses the energy. So that steam pushes on those turbines, and then that resistance is how we create our energy. And that will do it for lesson 1.